This is section 5.5, properties of logs. So now we're going to get some rules that we will use to either condense to single logs or expand to multiple logs. So the main ones are right here. Log base a of 1 is 0. That means, and think about it, a to the 0 power equals 1. So no matter what number a is, that's a true statement. Log base a of a equals 1. That's saying a to the first power equals a. Anything to the first power will equal that number. So that's those logarithms. All right, now the second one is the product rule. Log base a of m plus log base a of n. So you've got the same base, different arguments. You can write that as log base a of the product. So addition can condense to product. Same thing with subtraction. It can condense to a division. It's called the quotient rule. The power rule says if you have log base a of m to the r, log base a, m to the r, whatever the exponent is, can come to the front, and it gets the exponents down in the line. Let's see how some of these work in some examples before our problems. All right, log base 6 of z over z. We know that this is a quotient, so remember it's going to expand to a subtraction. So we have log of 6 minus log of z. All right. The second one is a product. We've got all these multiplied together. So we will break that apart into an addition. We've got log base 2 of 4 plus log base 2 of k squared plus log base 2 of x cubed. All right, so that's the first step. Then we can bring these powers to the front. So we would have log base 2 of k plus 3 log base 2 of x. And then we have to look at this one. And we look when it's two numbers to see if we can evaluate it. Log base 2 of 4, that's saying 2 to what power gives me 4? Well, that's 2. So we just write the plain 2 plus. And there you go. We've expanded this product into the addition. All right, on this one, we should recognize that we have a quotient, but up here, we also have a product. When you do this, you want to do the quotient thing first, which is subtraction. Log base 5 of 25x cubed minus log base 5 of y to the 4th. And then we're going to take care of this product. We're going to say log base 5 of 25 plus log base 5 of x cubed minus log base 5 of y to the 4th. All right, powers can come to the front, and we need to evaluate that. 5 to what power equals 25? That's going to be 2 plus 3 log base 5 of x minus 4 log base 5 of y. The last two, we're working backwards. We now have a sum of logs, and we want to write as a single log. Addition becomes multiplication. And we've got log of 2 times 3, which is the log of 6. Okay. Here we've got 3 things, and when you've got different things, you want to go in order. So the first thing is an addition, so that's going to become the log of 4 times 3 minus the log of 2 or the log of 12 minus log 2. Now we have subtraction, which can be written. We can go further and write it as a quotient. Log of 12 over 2, which gives us log 6. So those are our examples of using our rules that we have. So now let's look at the problems and see how we can do. All right, this one says express as a difference of logs. So we've got a quotient will become a subtraction. You look here to see if that can evaluate to something, and it can't. We can't go any simpler than that. So that would be your answer. Here we have a product. So let's, after we recognize that, let's go ahead and write that out. Log base 8 of 64 plus log base 8 of k squared plus log base 8 of x. Can we evaluate this one? 8 to some power equals 64? Yes, that is a 2. We're going to bring that power down. And we have log base 8 of x. All right, this one's multiple choice, but we're just going to go ahead and work it, and then we'll try to match our answer. Quotient first, so let's fix that. ln of xy to the 7th minus ln z to the 5th. Then we recognize that this is a product, so we're going to separate that into addition, sorry. So we have ln x plus ln y to the 7th minus ln z to the 5th. All right, we can do one more thing and bring the powers down. Ln x plus 7 ln y minus 5 ln z. All right. Now we're going to expand this one, and when you see the radicals, before you start the problem, you want to rewrite it to make it easier. So if this, remember that rule that we had, the index is the denominator of the fraction, and there's an understood 1 out here. So we could rewrite this as x squared minus 7 to the 1/4 over 3 plus x squared to the 1/2. All right, so now we can start our process of expanding. All right, so this is a quotient. Let's do our subtraction thing first. So we have log 5 of x squared minus 7 to the 1/4 minus log base 5 of 3 plus x squared to the 1/2. All right, and then our powers can come to the front. So we have 1/4 log base 5 of x squared minus 7 minus 1/2 log base 5 3 plus x squared. And that would be your answer. Same process, just rewrite that and it'll make it easier to work with. All right, rewrite as a single log. All right, so on the top, well, this is just your answer down here. So this is an addition, so we're going to rewrite it as multiplication. So we have log of 4 times 54, and you just go one more step and actually do that multiplication, and you would have log of 216. Okay. All right, same thing on this one. We would have log 18 times 1/9, which gives us log 2. 18 times 1/9 would be 2. All right, number 7. Rewrite as a single log. So first of all, we have an addition. That's going to become log 7 times 9 minus log 3. So that's log 63 minus log 3. That's a subtraction. We'll make it a division, write it as a single one, which equals the log 21. And they've got the word log written there, so all you have to do is put in the 21. All right, write as a single log. This is a subtraction, so we would have ln 5x to the 8th over x to the 4th. If I could write, we'd be good. You want to simplify. X to the 8th over x to the 4th would just be x to the 4th up here. So we would have ln 5x to the 4th. And again, you're just plugging that in. All right, let's do the same thing here. We're going to condense this. The first two become a, well, before we do that, let's do these powers. Let's take this 2 and put it on the power and 3 there. So we would have 5 ln x. I'm sorry, I forgot that's going there. All right, so we've got ln x to the 5th plus ln y squared minus ln z cubed. Then we'll combine this one, so we have ln of x to the 5th y squared minus ln z cubed. That's a subtraction. It will become a quotient, so we have ln x to the 5th y squared over z cubed. And that will be, we'll have to write in the whole thing on this one because it doesn't have it. All right, we're going to use our calculator to try to match a graph here. Let's go to y equals and clear this. Log base 2 of x. So we're going to have to use our change of base formula to actually get that to work. So you're going to put in log of the argument. So we're going to put log x, close, divided by log 2. All right, and then we'll do a zoom 6 and see what picture we get. Now their graphs are based on a little bit different window, but can we see which one it would be? We can tell it is this one. So remember that we put in, that we use the change of base formula. And we put in log x divided by log 2. All right, let's do this one. And we would put into y1 log absolute value of 5x divided by log 6. Let's see what we get. Clear that out. Log absolute value, second catalog will get you that. And we're going to put 5x in the middle. We're going to use our right arrow to go outside that, divided by log 6, and graph. So we have something, and our windows are not the same, and you could see if we did it, we might see a little bit different. Let's just do that to make sure you can see that well. And that's really due to that absolute value, and so we can see we have this one here as our graph. All right, we're doing the same thing here. We're doing that on the calculator. And we're going to do log of 90 divided by log of 6. And it does say round to 4 decimal places. So, let's see, did I? Oh, I don't know why I used 6. Okay, let's go back in. I don't know where I got 6. I think that's a 7. Enter. Okay, and so I know what I had for the answer and it's not there. And so this is really good for you to see the easy mistake one can make. I didn't close this parentheses after the 90, and so it's taking the log of all of this instead of the log of 90 closed divided by. So let's do this again and make sure we get it right. So I'm glad actually that I did that, and you could see that mistake in process. Divided by log 7 close. All right, let's see. There we go. That's the number I needed. So it's 2.3124. So 2.3124. Just be really careful. Make sure you close things when you need to do that. All right, 13, same thing. You're going to do log 30 in parentheses divided by log 7. And you should get 1.7479. All right, now this next one's an interesting question. Solve the equation graphically. So here is an equation, and we need to make that equal to 0. So let's move that 2 over. We have log base 3 of x cubed plus x squared plus 1 minus 2 equals 0. So this is going to be our y1, and this will be our y2. So here we go. Let's go ahead and do it here. All right, so in y1, I'm going to have log of log of the argument divided by the log of the base. Okay, so and I actually am doing that part first. So I'll have x cubed plus x squared plus 1. So log of that divided by log 3, close, and close again. No, I think maybe I don't have to do that. Maybe I can just do a minus 2. Let's see if that works. And a y2 to be 0. Let's see that. Okay, I believe that's correct. Let's see. Now let's find the intersection. So if I put this down here, this is what we're going to do. We're looking for that point right there. So second calc 5, enter, enter, enter. And that is our answer. Let me put that one over here. So that a little bit bigger. And you can see your answer should be 1.716, and it's 3 decimal places. So 1.716. So let me also put here our y equals screen. Oh, it's not going to show. I will write that down the way we had to do it, because we had to use right here to do this log. We had to write it in as change of base. So we had log of x cubed plus x squared plus 1 divided by log 2, and then we had a minus 2. So that was in y1, and y2 was equal to 0. And that's how we would get that solution. And that gets you some good practice on properties of logs.